Assalamu alaikum. This is Junaid Iqbal, and today I'm going to discuss one very important concept regarding the probability independent events, and this is with regards to O-level IGCSE and O-level GCSE at Excel board. So our topic of discussion today is independent events in probability. So when I talk about independent events, I want to explain that one event does not have any impact on other event. One event, let's say any event P of A, it does not have any impact on another event. So its formula is basically they're independent of each other. So its formula basically is P intersection B, and we just multiply both the probabilities. So let's just take an example. Let's say you have a coin and a dice. Okay, so let's say you have a coin, you flip a coin and you roll a dice. So this is event A, which is coin. Let's say I'm saying it C for coin. Okay, so event B is for dice, so I'm labeling it with dice. So let's say they're asking it find the probability that you get a head in coin. Sorry, you get a, yes, you get a head in coin, that's right. And you get a, let's say 4 in dice. First of all, we have to find the probability of head in coin and 4. So instead of C, let me just put H here because I want to find the probability of head in the coin and 4 in the dice. So it would be head. So head means head is one event in coin, and there are head and tail two possibilities, which is a sample space. So 1/2 is the probability of head, and probability of 4 in the dice would be 4 is one event, and you have 6 sample spaces because you have 1 2 3 4 5 6. So that is the probability of getting 4 in the dice. So what I'm going to do, I'm going to find both of them occurring together. Like in the coin you're getting head, and in the dice you're getting 4. So these are independent even. It does not matter that you get anything on the coin and you get any number on the coin. So they are independent. So what I'm going to do, I'm going to put intersection between both of them, and I'm going to multiply their probability. That's it, you have to do. So it would be 1/2 for head and 1/6 for 4. So altogether you're going to get 1/12. So that's it. This is for independent events where we have two events occurring simultaneously, but both are independent of each other. I hope that gives you some idea. Okay, so let's take one example. Okay, so let's say we have a bag which has 6 blue marbles and 4 red marbles. So a bag, 6 blue marbles and 4 red marbles. Okay, and you have 2 attempts. So in the first attempt you have to find the probability that you pick 2 blue marbles. Okay, so now we have 2 conditions here. Right now they can ask you with replacement, and they can ask you without replacement. Okay, so first I'm going to do start with without replacement, but I want to explain both of them, So let's say this is a bag, and these are 6 blue and 4 red marbles. Okay, so let's say 6 blue, 1, 2, 3, 4, 5, 6, and 4 red marbles. So now first we are going for without replacement. Now let's say you pick one blue. Okay, now this blue is gone. There is nothing here. So it's without replacement. You're not going to put it back. Okay, uh, you're not going to put it back, and you're going to, now in the second attempt you are going to select another one. Let's say you select another blue. Now this is also gone because you are not replacing it. Now after the first attempt you have 9 remaining, including this, and after the second event you have 8 remaining. So I'm going to start with without replacement, and they will mention you in the question in the IGCSE and both in the edXL. So if I want to do this question without replacement, like in the first attempt picking blue, and the second attempt picking blue. So first of all, I have to see I have 6 blue marbles, and the probability of finding blue is 6 upon overall 10, right? And this is B1 because this is first attempt. And in the second attempt, if I'm taking another blue, so now blue, one blue is gone, one blue is reduced. Now you have total 9 sample space, and you have blue 5 remaining. So this is what I have to do. I have to reduce the denominator as well as numerator because blue will be reduced by 1. So this is the without replacement condition when you are not replacing the ball back into the bag. So now if I want to find the probability of selecting blue first, then also blue. So it would be B1. By the way, I'm mentioning it with B1 and B2 because the number are reduced for blue. No? So it would be 6 upon 10 in the first attempt and 5 upon 9 in the second attempt. So if I multiply them, it would be 30 divided by 90. So 1 upon 3. So that is what I'm going to get. So I'm going to do the same question with replacement. Now with replacement means I'm going to select blue first, then I'm going to put it back. When I'm taking the blue one and I'm putting it back, like keeping the number of total sample space as same. But this is replacement. So in replacement condition, if I'm going to pick the blue B1, that is going to be 6 upon 10. And in the second attempt, if I'm going to pick the blue one, that would be 6 upon 10 because the number of balls are not reduced here. So with replacement condition, it would be the multiplication would be the same because for independent events, we are always going to multiply both the probabilities, and that would be 6 upon 10, 6 upon 10, and 36 upon 100. We are going to simplify it, and we are going to do. So 9 upon 25 would be the probabilities of picking blue first and then blue first without replacement. Yeah. So, okay, so that's it. Let's move forward with another basically topic for probability. So probability, now we are going to discuss, yes. So yes, so we are going to discuss conditional probability now. And by the way, this thing can be used for dependent events also. The same condition, you know. Let's just do some dependent events question. Dependent events are those where occurrence of one event impact other. Okay, so let's take an example. Let's say a box contains 7 green pens and 3 black pens. Let's say, let me write it in black. A box contain 7 black pens and 3 blue pens. And so 2 pens are picked without replacement. So we have to find the probability that pens are black and blue. Like the first pen will be black and the second pen will be blue. So if I find the probability of black, I'm writing it BLA. So it would be 7 upon 10 because 10 is the total sample space. And for blue, the second event. So in the second event, if I'm doing the blue stuff, my total number of sample space would be reduced by 1 and that would be 9. And the blue pens are 3. So black and blue. So it would be 7 upon 10 and 3 upon 9. Now we are going to simplify it. So it would be 21, 90, 30. Okay, so this is what dependent events, when first event is impacting the other. If you are picking up the black, obviously we are going to have a reduced sample space, and it would be reduced from 10 to 9, and this would be 3 upon 9. Okay, so now let's move to conditional probability. Okay. So conditional probability is a very interesting topic. And let me just write a very simple notation of it. It says that probability of A happening provided B has already happened. Okay. So let me just give you a very small example. Let's say you are saying that probability of person uh, being, being sick, provided that his test results are positive. So test results are positive is the condition we will be using here, and the person being sick is this. This is the condition which we will be using. So probability of sick being positive, provided it is positive. So this is what we have to do in conditional probability. Let's just go through a few examples that would basically clear that concept more. So let me give you a very let me give you a table. Now let's see. This is a class in a school, and it has distribution like there's a boys and girls, and they have been categorized. The boys who are playing football, they are 30. The boys who are playing basketball, they are 10. The total boys are 40. Similarly, the girls which are playing football are 15. The girls which are playing basketball are 25. The girls total are 40. And the total number of students who are playing football, including boys and girls, are 45. The total number of students who are playing basketball, including boys and girls, they are 35. And 80 are the total number of students, boys and girls. So let's say you have been asked to find the probability find probability that student plays football provided that she is a girl. Okay, so being a girl is a condition and she's playing football. Okay, so based on that particular formula which I told you, in this condition, this is being a girl and plays football. So it would be football intersection girl and girl. But this basically football intersection girl, which we can find with the help of, now just consider this football, move downwards to this column because football is in the column and girls is in the row. So just move and see which one is intersecting. So this one is basically intersecting both football and girl. Okay, total number are 80. Getting it? So it would be probability of football intersection girl would be this 15 over 80. And similarly, probability of girl would be the total number of girls are 40. These are the total number of girls and total number of students are 80 again. So 40 over 80. We can cancel out 80 and 80 and we can write 15 over 40 and just cancel it out. So probability of a student playing football, provided she's a girl, is 3 upon it. So this is how basically we are going to find. So we have to find the intersection of both the events. Move from column and then move from row, and then we have to in denominator put the condition. So I hope this is a bit clear to you. Okay, another topic which I want to discuss, since it's a demo lecture, so I'm going to discuss all the topics very briefly. Tree diagram. Tree diagram is a very interesting topic in which and it is for dependent events basically. So oh, it's for both independent and dependent events basically. So let's just do this. Let me just paste a question for you. I hope it is visible. I'm just increasing its size. Okay. So weather and mood condition. So it says the probability that it will rain is 0.4 and the probability that I'm going to be sad is going to be 0.9. So if it is sunny, like it's not raining, the probability I'm going to be, I think that's going to be a bit difficult example. Let's just keep it now because we are just starting this topic. Let's move it to some other example because right now in this question we have not raining condition also, sunny condition. So I don't want to basically move here. So this question would be much better to understand tree diagram. Mm, this one. Okay. So a drawer has 6 black and 4 white socks. So in total, there are 10 socks. So if I find the probability of black, it would be 6 upon 10 and 3 upon 5. And probability of white socks would be 4 upon 10 and 2 over 5. So find the probability they are different colors. So different colors means if you pick blue first, then second should be white. And if you pick white first, then second should be blue. Now you have to do it with tree diagram. So let's say first you pick blue. Let's start with that. And in another scenario, in the first you pick white. So after blue, they could be blue again, they could be white. Although we are interested in blue and white, there are two different colors. And similarly, if you pick white in the first attempt, and the second attempt it could be blue again, and it could be white. So we have to put the probability of each event. So probability of B is 3 over 5, and probability of white is 2 over 5. Again, probability of B is 3 over 5. Probability of white is 2 over 5. Probability of blue is 3 over 5. Probability of white is 2 over 5. So our interest is we have to find different, basically. So we have to find probability of first blue and white. So first blue and then white. So these are the events, basically. So for first blue and white, we'll do intersection and we just multiply them, right? So 3 over 5, 2 over 5, it's going to be 6 over 25. Similarly, white and blue, because these are the different events, you pick first white and then blue. So they are going to be 2 over 5 and 3 over 5. So 6 over 25. Now you have to combine them because there can be two conditions. So you have to combine them by adding. So you just add 6 over 25 and 6 over 25 and it would be 12 over 25. So this is how you're gonna find the socks which are different colors, blue and white or white and blue. So this plus is for or. So I hope this concept is clear. Okay. So let's keep it till there for this demo. Inshallah, in the next coming demos, I'll be discussing some more topics, and this might help you, all the students who are taking IGCSE or edX. Okay, take care. Thanks for watching. Assalamu alaikum.